guys, tonight we're gonna do a complex centroid because a few of you have been asking about them. So I have a complex centroid up here in the top left corner. Essentially it is going to be a square, a triangle, and a semicircle. So what we're gonna do first is we're going to just break it up into those things. So I'm just gonna do a dotted line to show the semicircle and dotted line to show the triangle. Now you notice this triangle is a right triangle, and how do we know that? Because we made it. This is a horizontal line. This is a vertical line, so that's going to be a 90-degree angle. That's important for us to know because it makes our lives a whole lot easier when doing the math. Okay, so what we're going to do is we're going to start by, what I do is I just draw in where I think those centroids are, just to give an idea. It helps me give a visualization reference. And then what we're going to do is we're going to start off by identifying any of the sizes that aren't posted on here. So for instance, we know this radius is 5. That means that this whole distance right here is going to be 10, and that means that if that's 10, then this is 10, and this is 10, which is good because it makes it a whole lot easier on us. Alright, so what we're going to do is we're going to make a table, and the table is depending on how many shapes you have. So here we have 3 shapes, so our table is going to have 3 shapes, and essentially it's going to have 4 columns, and there's our square, triangle, semicircle, and we'll do a spot for the total on the bottom. We're going to have a table for the X, and we're going to have a table for the Y's. So we're going to make that happen. Apologize for my drawing skills today. Not exactly the straightest lines. Okay, so we're going to come over here and we're going to put square. We're going to put triangle. Ooh. And we're going to put semicircle. And you can just put T down here for total because that's the total roll. And we're going to cross that out. We're going to cross this out. We're going to put A, X, and AX. We're going to put A, Y, and AY. Alright. So, taking a look at this, what we're going to do is we're going to do our areas, because this is our area. That's our along our X, and this is the combo between this and this. So this times this equals this column. So let's start with the area. The area of this square is a 10-inch by 10-inch square. So 10 times 10, we're going to get 100. And we're going to put that in both spots. Triangle. It is a 10 by 10 triangle. So we're going to do 10 times 10 divided by 2 because it is a triangle, so it's half of that square, and we're going to get 50. Alright, and then the semicircle. Semicircle area is going to be pi r squared, so pi times 5 squared, so pi times 25. And we're gonna get about 78, I believe, but that's a whole circle. We have to cut that in half. So we have to take that number, we have to divide by 2. So we're gonna get about 39.3. 39.3. Apologize for that. Should have made those tables a little bit bigger. Okay, and what we're going to do is we're going to total these up. So 100 plus 50 plus 39.9 we get 189.3. 189.3. Great. Alright, we're going to work our way even farther around here. We're going to look at the x's. So for the square, along the x-axis, how far is it from here to here? Well, it's 10 divided by 2, which is 5. Awesome. Take a look at our triangle. We're going to do, for a triangle, we're going to do 10 divided by 3. And we get 3.33. Now, that is the distance from here to this line. So essentially, that's the distance from this to this. 3.33. Oh, we need more than that. We need the distance from the centroid all the way over. So this is 10, that's 3.33. So we're going to add them together, we get 13.33. That's probably one of the biggest things that people make a mistake on, is they don't include the entire distance in their shapes. And last but not least is a semicircle. I probably shouldn't have drew it there, but that's okay. Actually, I'm going to do that again. Use the undo button, do it up here. So from here to here, that whole semicircle is 10 wide. So we're just taking the radius in the x direction. So it's going to be 5. Okay, we're going to do a little math. So 100 times 5 is 500. 50 times 13.33, 665. I rounded a little bit, so just so you know. And then 39.3 times 5 is 196.5. In this column, in total, we're going to add them together. Add all those up, and we're going to get a number. And of course, I forgot to write it down. 665, 96.5. So 1361.5. 1361.5. Alright, so let's just finish that up. Sum of all forces. Yeah, sum of all forces. Got trusses on my mind. Sum of all the AX's divided by the sum of all the areas is how you find that final x. So we're going to take this number here and we're going to divide it by this number. So 1361 divided by 189.3, and we get, so 1361.5 divided by 189.3, we get a final x of 7.19 inches. Great. So let's jump over here. And we're going to take our same thing here. We're going to do the y's. So, and I'll switch over to a different color here. Do orange. In the y direction for the square, how far is it from here to here? Well, it's a square, so 10 divided by 2 is 5. That means this is 500. Triangle. How far is it from here to here? Well, 10 divided by 3, 3.33. And that is coming from that bottom, coming from the right angle. So 3.33. And last but not least, it's a semicircle. Semicircles are the ones that get everybody. So the semicircle formula is 4r divided by 3 pi. So we have 4 times 5 divided by 3 pi. So we get 20 divided by 3 pi. And I get a number that is 20 divided by 3 pi. Make sure you do that 3 pi by itself. That's one thing that people make a mistake on. I get 2.12. Now, that distance comes from the centroid to the straight edge of that semicircle. So 2.12. That is not the distance we need. We need the distance from here all the way down to here. So we know from here to here is 10. So 10 plus 2.12 is going to be 12.12. And we can do a little multiplication, 166.5, which is the 3.33 times 50, and 12.12 times 39.3, 476.3. Doing a little addition, add them up, 1,142.8, and then jump back over sum of all a y's, sum of all a's. So 1142.8, 189.3. So 1142.8 divided by 189.3, and I get about 6.04. So I get a final y of 6.04 inches. Now, what I do is I just do myself a big favor and I throw that centroid on the shape just to make sure it makes sense. So, in the x direction, we're 7.19 over. So, here's 5, here's 10. So, somewhere in between here. So, probably just about here, somewhere in here. And then about 6.4 up. So, this is 5 up. So, probably somewhere about right there is what we're finding is our centroid. And this isn't to scale 100%, but it's pretty darn close. I would say that that's a pretty reasonable calculation of a centroid. Point is, it's not like way out here, right? Because remember, it's got to be within the perimeter of the outside of the shape, right? Or within the perimeter of the shape. So it can't be way out here, it can't be way down here. It's not going to be all the way down here. So you guys get it. It's going to be right there, which is what we calculated. So just pay attention to a couple things, a couple key areas that people make mistakes on. If I can point them out to you. Triangles and semicircles. Mainly on this stuff right here. Those X's and those Y's. That's a couple key areas. Another couple areas, they don't divide by 2 for the triangle, and they don't divide by 2 for the area of a semicircle. That's probably the 4 major areas that people make mistakes on. So if you have any questions, feel free to comment below, and I can help you, or maybe one of the other viewers can help you. Alright guys, have a good night, and I look forward to hearing from you later.